Good morning, everyone. My name is Miss KM. Welcome back to my channel. I hope you're all doing fine and great because I am. Today, I'm going to be talking about grade 10 chemistry, and the first topic I'm going to talk about is stoichiometry. Stoichiometry plays a huge role in chemistry, especially in grade 10 in term 3 where you're going to learn about this. So first of all, what is stoichiometry? Stoichiometry is part of chemistry that looks at the relative quantities of reactants and products in chemical reactions. I'll repeat myself again. What is stoichiometry? Stoichiometry is part of chemistry, okay? It looks at the relative quantities of reactants and products in chemical reactions. And sometimes when the first time my teacher mentioned stoichiometry, everyone was thinking trigonometry. It's giving trigonometry vibes because it's similar to the name of trigonometry, but actually it's not. But very good guess though. Stoichiometry refers to calculations, okay? Because in physics, there's a physics side of theory and there's a chemistry side, okay? So this is the chemistry side of physics in general, which is stoichiometry, like I just mentioned just now. We use stoichiometry to calculate quantities, okay? Quantities like the amount of products in mass, okay, in mass or moles and volume that can be produced with given reactants, okay? So I'll just repeat myself again if you guys didn't hear me. We use stoichiometry to calculate, okay? To calculate quantities, to calculate, think of quantities as capacities, okay? To calculate quantities like the amount of products in mass, in moles, in volume, okay? Now that's done. Now as you can see here, this is the first triangle, and I'm sure you're thinking, oh, it's giving the V over I and then R over here, the voltage. No. If you guys are thinking that, then well done, good guess, but no, not that, okay? This is the first stoichiometric triangle, okay? So first of all, this is N. N, and this is the small letter N, and this is the NA. Okay, I'm sure your teacher have gone through this with you, but I'm going to go with the first triangle. Okay, so this over here, I'm just going to give a brief introduction, and then the next video, I'm going to be doing the calculations. Okay, so first of all, just a brief explanation. This big letter N, okay, as I just jotted down here for you guys, it represents the number of particles, the number of ions, the number of molecules, even the number of atoms. So if they say calculate this big letter N, then you're gonna say, oh, first the question they might ask you is how many electrons or how many ions or how many molecules or etc. Even if it's not in the list here, if they say calculate the number of certain things, what, right? You're going to use this formula over here, this triangle, and I basically jotted it down for you in simpler terms so that you guys can understand. This small letter N, okay, it's the number of moles, and the unit for that is just moles without the E though, and just the S at the end. And then Na. What is Na? Na is Avogadro's group, or Avogadro's constant, basically, okay? And the constant remains the same, and up till matric, it remains the same. It doesn't change at all, okay? So this constant is always 6.022 multiplied by 10 to the power of 23. But sometimes they give you a rounded off answer where there's only like 2, like for example 6.02 times 10 to the power of 23. It's still the same. It's still gonna give you the same answer on the calculator if you're gonna use this constant, you know what I mean? If you guys understand what I'm trying to say is sometimes in the exam, or if they give you an answer sheet or something, then sometimes it appears like this, okay? Sometimes your teacher can give it to you like this or like this. That's just how I jotted it down here for you if you guys didn't understand what I meant. It's still the same thing. This is just a rounded off answer of this. It's still the same thing. It doesn't change. Your answer will still give you the same answer. Nothing is going to change. Okay? So don't worry about that. Now, over here, I'm sure you guys are wondering, what did Chira, did you write scribbles here? No, guys. What I wrote here is because you guys, some of you guys and other peers as well, they also like to write down, they also like to memorize things like this. But why memorize and like hurt yourself instead of just using this triangle, because this triangle is here for a reason. If it wasn't here, then you would have to memorize all this, and this is going to give your mind, your head a brain a headache. So that's why I say don't memorize this, use this triangle. But what I did is I just broke it down for you guys if you didn't understand. You see this line over here? This line is a division line, okay, and this line is a multiplication line. Like if it's next to each other, multiplication. If it's just over like this, it's division. Okay, so if they say calculate the number of moles, like I just mentioned over here, okay, if they say calculate the number of moles, you're gonna say n, capital letter N, over your Avogadro's constant. Okay, if you want to calculate the big letter N, you're gonna say the small letter N, like I just mentioned now, the multiplication line, N multiplied by Na. Okay, now the last one, which is your Avogadro's constant. I'm not sure, they usually don't give us something like this. If they say calculate the Avogadro's constant, it doesn't actually happen like that. But I just wrote this down for you, just for you guys to get an understanding of what this triangle is basically saying. Okay, I just broke it down, so don't stress about this. This is not really necessary in terms of this time, but maybe your teacher will tell you, I don't know. So Avogadro's constant is equal to N over small letter n. Okay, what is a mole? Okay, a mole of any substance is defined as the amount of that substance. That is what a mole is. This is basically the mole constant of stoichiometry. Okay guys, before, I just want to round up everything of my introduction today. So what I'm going to say is stoichiometry, use stoichiometry for calculations, and there are more and more triangles other than this one, so be prepared. And we use stoichiometry for calculations, like I just said now, for the amount of products in moles, in volumes, in mass, and etc. And it can also be produced with given reactants. Okay, it's part of chemistry that looks at the relative quantities of reactants and products in reactions. Okay, the mole is a unit of measurement and expresses the amount of a chemical substance. Like I just said now earlier, a mole of any substance is defined as the amount of that substance. Okay, we use mole as a unit of measurement because the size of atoms and ions and molecules is so small. Okay, thank you all for watching. I really hope you enjoyed this video. This is basically a brief introduction. In the next video, I'm going to be giving you examples and exercises and the calculations of how to use this. Thank you so much for watching my video. Don't forget to like, subscribe, and hit that subscribe button for more notification of my next new video. Thank you guys. Bye.